Hello, everyone. Welcome back. Can you hear me? All right, can you all see my screen? All right. All right. Welcome back. All right, let's take a look at where we've been, where we are, and where we're going. Let's see. All right, let's see. Let's take a look at the syllabus. Okay. All right, let's see. We are getting started in our 4th week. And let's see. So the topic for this week will be JavaScript. Up until this point, everything we've created has been static content, just using HTML and CSS to describe the content and then style it to look pretty, and Bootstrap to make it even more prettier, look more presentable and professional, and be responsive and whatnot, right? But it has all been declarative. You declare that things look this way, right? That this is on the left, this is on the right, and this is how it should behave, right? So it's all declarative programming. So today we're going to start looking at functional programming using JavaScript as the programming language of the web. We're going to learn the basics of the language, including the legacy ES5, as well as the new syntax ES6 going forward. And also, we're going to introduce jQuery as a library to be able to manipulate the DOM, which is going to introduce the concept of being able to programmatically add content, remove content, modify content based on event handling. As users drag their mouse or they click on the screen or they type something on their keyboard, right? We want to be able to react to that and then dynamically decide what should be added, removed, updated, and whatnot, right? So we're going to be learning that today. Also, quiz 2 will be made available later today, and will be available for the next couple of days. The topic for this second quiz is CSS. And also today we're going to introduce the 5th assignment, which is all going to be on JavaScript. It's a chance for you to learn, to practice, and then to apply the JavaScript language. Again, same thing, right? All assignments, they build on each other. They have a lab section that has some standalone exercises for you to practice some skills. Then there's Twitter section that asks you to apply what you've learned to implement to build an application that we've been working throughout the semester, which is a social network that is based on a popular social network out there. And then for the graduate, they have an additional section where you have a challenge that goes a little beyond that. Okay, the assignment will be due on the 16th, so about a couple of weeks from now. And you're still working on the 4th assignment, which is due later this week. which is the Bootstrap assignment that you're practicing how to do things to be responsive. Use the Bootstrap libraries, several widgets that it has for tabs and lists and whatnot. Right, that's due later this week. The TAs are furiously working on grading the last two assignments, and we hope to have them soon. Let's see. Is there a question on the chat? All right, it says, hi, Professor, when will quiz 2 be up? Yeah, it'll be up right after we complete the lecture today, and will be available for the next couple of days. Yeah, it will be up today. It'll be up for the next 48 hours or so. All right. Okay, so let's get going. Right, so remember that I am providing the repository for all the source code that we've been working on together. It's always going to be available here in the at the top of the home modules, so you should be able to take a look at that. And again, any source code that I give you or repository that I share with you, feel free to copy and paste from anything we work on together here in lecture. So we've gone through several of these modules already. So we've done the setup, HTML, CSS. Last week we did Bootstrap, and this week we're focusing on JavaScript. Okay. So JavaScript is a programming language that it's I mean, it's mostly known to be the programming language of the web. Since that's where mostly it's used, but it has found its way beyond the browser, right? That we can be used also to implement server-side programming or desktop programming. So it's become a much more general purpose language. But yes, it has its beginnings as it's famous for being able to program the browsers. Okay, and so you'll see a lot of examples, at least in the first half of the semester, of using JavaScript exclusively running on the browser. So it's code that runs on the browser, like this browser you see here, right? With all these tabs and whatnot, and embedded inside of HTML documents, right? Once we complete when we start the second half of the semester, we start using JavaScript outside of the browser, right, to implement server side or run things on the console on a desktop. Okay, so that's going to be the second half of the semester. So for the first half of the semester, within HTML documents, you can embed tag inside a tag. Inside HTML, you can use script tag, right, to be able to include executable code functions, right, functions that are already declared, such as alert, and you can create your own functions, libraries, and whatnot. Okay, so here's alert, right? That, as you would expect, it pops up a document, right? And there's console that you can write to the console. Yeah, remember that all browsers, right? All browsers you can inspect, right? And you have a console. You can look at the DOM here, right? That you can take a look at all the body, the divs, each one of the divs, each one of the spans. Okay, but also notice there's a console here. See that console? So this console allows you to interact with the programmatic side of websites. Okay, you can look at source code. You can step through source code, put breakpoints. You can look at the call stack, so you can debug it. And so within the browser, you have an entire development environment, right? Well, mostly debugging environment, where you can look at the user interface through the elements. You can see the code that generates the user interface. But then also within, you can look at the source code. Any JavaScript libraries that were loaded within the HTML document are available through here, and you can step through and whatnot. You can view any JavaScript files that are loaded by the browser, as well as you can console log. You can log write stuff to the console, and you can see it here. Yeah. Plus, you can, if you're doing some network communication, right? If your JavaScript is communicating with all sorts of third-party APIs, right? You can take a look at those communications through the network tab. But we'll do much more of this in the second half of the semester. Okay. Okay. So yeah. So you have commands such as console. You can write to the DOM. You can manipulate the DOM. This is a global object, the document, which is programmatically tied to this, right? To this HTML here, right? So so that through the document object, you can write, right? You can programmatically write to this DOM element, right? You can append, you can remove, you can search the tree, you can find elements in the DOM through some attributes or classes. You know, so you can say, find me the header element whose class is yada yada yada, right? So you can grab that node, right, and then say, okay, remove it, right, or clone it, or modify its contents, or change its style programmatically. Okay, and so JavaScript has a low-level API, right, that allows you to retrieve things from the DOM, right? You can retrieve an element in the DOM uh, through its ID. If there's an ID equal hello, well, you can say document. So document is the object that represents the DOM, the document object model, right? It is the data structure that holds the entire document programmatically. It's all these nodes. All these nodes, right, are represented through this one object, the document object, right? That then allows you to have functions that allow you to navigate the DOM, just traverse your tree, going down or up, right, to your siblings. It allows you to traverse all that tree. Here's find me an element who has a particular ID, and so it finds an H1 that has that ID. Or find me an element who has an ID of hello, right? And once you have the elements, right, you can assign the elements to a local variable using things such as let. You can declare a variable and assign references to elements that you find in the DOM. You can assign it to a local variable so that you can then manipulate its attributes, such as all elements have a style attribute, right, which is the, if you remember in HTML, each element had a style attribute. You can say style equal, and then you can change the color, the background color, the foreground color, borders, margins, blah, 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 right? The thing that we told you not to do, right? We said that, declare it in the link, declare it in a separate CSS file, right? That's declarative, right? Using the HTML and CSS, but programmatically, you can manipulate individual nodes in the tree and say, I want this particular element to have a foreground color of red. Okay. Or you can change the font size, and there's tons and tons of these attributes. You can display none, right? So you can just hide it, and so it's just not displayed, it's gone. You have data types such as dates, numbers, strings, Boolean, and you can create new instances of these objects, dates, and then you can write to the elements to the DOM. Okay. Obviously, you have arrays that you can iterate over, right? Where you can display things into the DOM. You can iterate over arrays. Obviously doing arithmetics such as adding and accumulating, and calculating the average, and then writing to the DOM. You can dynamically generate content, right? So let's play around with this a little bit. So let's look at here. So let's see. So okay, these are not labs. So I'll call it lectures. So lectures. And this is for JavaScript. So let's play around a little bit here. So let's create an HTML document. So let's take a look at some of the examples that we have here. So for instance, just a couple things. So this hello. So if we say this is let's do H1. Welcome to JavaScript. Let's not do the scripts yet. Let's run this. Run. And right now it's just welcome to JavaScript, so nothing weird there. So let's put this on the right hand side here. Let's put the IDE on the left. There we go. Welcome to JavaScript. Okay, and if you uncomment the script and you refresh, right, it executes the alert. See that, the script, whatever commands you have there. There we go. And then of course, in that same script, right? You can do comments like you would any programming language. You can do console log, right? It says hello world, right? So if I refresh, you would not see anything. You would see it in the console. If you do inspect, if you click on the console, that's where you would see the content. See that? Hello world. It's this over here. It also tells you where it got printed. It got printed from index.html. Right? You could look at the source code. Right, here's the HTML, and you can see the source code here. There it is, console. And you can even put a breakpoint. Right? So if I refresh, it stops until you can continue the debugger. Okay. All right. So let's take a look at a few other examples. Console. Now document write. So document write. Let's do that. And if you refresh, let's take out the breakpoint. Let's continue. So notice what it's doing, right? It's writing to the document, right? So this is not the console. Let's remove the console. This removes, says hello world. How are you? So if you refresh, so this is adding to the document. Basically here we have the H1 that was read from the HTML, right? So let's make this a little bigger. And let's make this so you can see better. So this document write dynamically added to the HTML. So if you go to the elements, you'll see that you have the body, right? You have the H1. The H1 was read from the file. There it is. The script tag was also read from the file, right? This was read from the file. Okay, but the how are you was not there in the original file. See that? The original file didn't have how are you. We wrote to the document, right? The how are you, and you can actually have this to be inside of an H2. You can write proper HTML. Right, so if I refresh, notice that this is indeed H2. See that? How are you? We dynamically added there. So you can get you can use this very well. So for instance, to a loop, right? You can declare a constant that has maybe grades where you got a 90, so 99, 90, 89, 78, and 67. Okay. So you could say document dot write, maybe in a you say in a label, you can say grades. Oops. And you can embed. There's a way to embed things inside of strings. So you can put expressions inside of strings using not the double quotes, but the backticks. The backticks allow you to embed variables inside of strings. So that's a string, label, close label, it's a string, but inside you can put expressions. You can say $, curly bracket, right? You can say, well, there's a variable called grades, and I want to know the length of that array, right? So if I refresh, there it is, right? Here's label 4. See that? Then you can maybe document, write a an opening H2 UL, and maybe close it. You close the UL. Okay, and then in here you can have several LI. So this is an LI, and this is this is let's see, it could be an expression. So this could be the grade sub 0, right? And maybe this is grade sub 1, sub 2. So if I render it, there it is, right? 90, 89, and 78. So there's a nice thing about the backticks is that you can put this all in one single line, right? You can say document write, right? You can put a backtick, right? You can say you can open up a UL, right? And let's put this here so that they're nice, and there we go, like that. Oops. There you go. And so now it's as if this were just a plain old HTML. You can put the LI here. And this is grade sub 0. Close it. And you can just copy this multiple times. So this is 1, 2, right? So if I refresh, there it is, same thing, right? Or you might say, well, this is a for loop, isn't it? This is a for loop. So I could have done this, right? I could have opened up the UL and close the UL. Close the UL. And then maybe had a for loop in between here. You say for let I equal 0, I less than grades sub length, and then I plus plus. Okay. And then as I iterate, I could append one of these LIs in between, right? And I could just iterate, and then that's just an I, like that. Okay. So let's refresh that. So let's give some of these labels here, because we have way too many examples of the same thing. So let's say document. This is maybe a H2. This is a hard coded list, right? So that's our first example. There it is. It's hard coded list. This is a list. This is using this backticks, right? And then being able to embed expressions inside of a string. Those are called template strings. So lists using template string. Right. So if I refresh, there it is. That's a same, right? And then this last example using an array. A for loop, sorry, a for loop. Right. It's this last example. Okay. Everybody good? That makes sense? Okay. All right. All right. Let's see. Any questions so far? I think it's pretty standard, programming language, right? Nothing weird. Okay. Obviously, we can calculate things here. We could say say let average equals 0. Let total equals 0. All right, and then we can say that the total is the grades, accumulated, right? And then we can calculate that the average is equal to the total divided by the length, right? And then we can say, then we can write perhaps in total, average, and probably this could be an expression, and we can embed here average. Okay. Okay. Everybody good? All right. Okay. Yeah. So let's keep going. See where we left off. Yeah. So document write. You can retrieve elements by their ID. Right. So if you have an element with its ID, so say you have welcome to JavaScript and this is ID welcome. Right. You grab it. You can say const hi. Right. We can grab it. We can say document. Oops. Document dot get element by ID, and the ID is welcome. Welcome. All right. And then you can use that variable because we grabbed it. We can style. Right, it has a style attribute of which has a whole bunch of features, fields that you can change. So you can say red, right, which is here. Right, notice that welcome to JavaScript is red. Okay, and there's tons of attributes that you can manipulate. Okay, let's see. You can manipulate the actual content by once you grab it, you can change its inner HTML. So this might say welcome to JavaScript, and this you can change it. You can say hi dot inner HTML. You can change it to welcome to web dev. So I'm going to change the inner HTML here. So at first, when it loads from the document, the DOM's value for that h1 inner, the inside of the HTML, is welcome to JavaScript. But we are going to programmatically modify its content to be welcome to web dev, right? So you're going to see it flicker for a second, right? It'll be welcome to JavaScript. It'll flicker real quick back to welcome to web dev, right? So if we refresh, there it is. So we have programmatically modified the node, right, to be web dev. See that? And so element, blah, blah, blah. Yeah, we can change the font size. We can just hide things and change the display to none, and then you would not see it, right? You can say, hi, dot style dot display equal none, right? So all the changes that we've made so far, making it red and changing the content, and then poof, it's gone, right? So you're not refresh, notice it's gone. Notice it's still there in the DOM, right? It says it is still in the DOM, but we're just not rendering it. We're saying don't render this, right? Display is none. So it's in the tree. It's just not being rendered. There's dates, right? We can look at dates, and that the assignment will work on that a little more. Dates have months, days, years, the full year. You can do iterate, right? Here's the scores. We saw this example before earlier. Not only can you render dynamic ULs, but you can render dynamic tables, right? Entire tables. You can, right? And so if you look at you can create functions, right? Where you might have here. Let's see. If you have a table, let's add the table earlier. Hard-coded lists. Let's create a table out of this, right? So you have length. Let's create a table here. So you have a table. table of grades. Okay, so obviously you can generate a table. Obviously, now if you say this is you can say this is table. Table. And let's close this table. Table. There we go. Oops. And this might be a table row, right? A table row that might contain several table columns, right? Table columns. And then maybe you have multiple table columns, and this could be maybe oops. Oh, we have so much space. Oh wow. Huh? What's going on? Ah! Okay, there we go. Okay, I just don't want to have extra spaces. And again, this could be, this is grades sub 0, right? And then you can just have a few of these. So this is 1 and then 2. And then I'm just going to change the border. Although borders has been deprecated, it's convenient just to display something real quick. So here's our table. Here's our table. So one of the things I would love to be able to do is that perhaps this could be a function, right? Which is that maybe calculates something and generates the content or iterates and whatnot. So for instance, this is a row, right? So maybe this could be, you could put a function here. So function row, right? Table row, table row. And this is maybe your grade value, and this is going to return, return a string that looks like this. Okay? So, for instance, you can break that up and say, okay, well, let me copy this. Right, where let's see. Okay. There you go. And so this just returns a grade like that, right? So this, right, this could be what? This could be the embedding of the expression, right? Table row, and you give it the grades of 0, right? Okay, and then you can do this multiple times, and then you can remove that. So this could be 1 and 2. See that? Right. So if I refresh, right, it just does the same thing. Now this allows me to now modularize this, right? So instead of having tons and tons of content, I can create now functions that can create subsets of elements or like little components that I can now manipulate, right? And instead of and be able to reuse them. So for instance, I could add another TD here that says grade. So add another column, right? So that's or maybe so I can now reuse it. Now the rows, right? The rows, this could be an iteration instead of doing all these, right? So I could say this could be a function. Function. These are table rows, maybe, right? Where you could get all grades, and then you want to iterate. Now the iteration is what? It's the accumulation of all the strings of calling this over and over and over, right? So you could do it this way. You could say let rows, right, equal an empty string, right? And then you're going to accumulate. You can say for let I equal 0, I less than grades dot length, right? And I plus plus, And then you could say, well, the all the rows is basically what? It's calling these table rows multiple times and just accumulating. You could say, rows plus equal table row, right? Grades sub I, something like that, right? And then you return rows. You return rows. So this would be what? Now this would be, the expression of table rows, and you pass it the grades, right? Okay. So let's refresh. Oops, something went wrong. Grade. Oh wait. Grades. Table rows. Grades. Grades. Oh, grades. Grades. There we go. Okay. So yeah, so it's going through all the grades. But there's an even cooler way of doing this. So basically, this accumulation of things is so common. It is so common in programming in general, but specifically in JavaScript, right? So the alternative of doing this is as follows. You could say grades, right? It's an array, right? I'm going to iterate over those arrays. And so as I iterate, I'm going to calculate something, and whatever gets accumulated, whatever the result is, it's going to be appended to rows, right? So for instance, I can say, iterate and call multiple times a function, call a function, a function like that, call this function, and so it's going to call each one of this, and so for each and it's going to pass you each element of the array. So here's your grade. Here's your grade. And what are you going to do with that function? Well, I'm just going to call table rows. I'm going to return grade. I'm going to call that, and I'm going to return this. I'm going to return. Okay. So it's a different way of doing this, right? So I'm going to accumulate many of these strings, right? And by whatever this returns. So this returns what? Returns this thing, right? Multiple times, and they get accumulated into rows, and then I return that. Okay. And now this returns an array. This returns an array. So basically, that's why those commas, those commas. So you need to join right, with the and join it into one single string, right? So just remove all those arrays. So now you're back to normal. That makes sense? Now with the new syntax, this can be even more terse as follows. So I'm just going to comment that out. This changes as follows, right? In the new syntax, you can drop the name of the function, right? And instead, you can have an arrows, right? So it becomes a little more compact. Okay, a little more compact. And if you refresh, notice the same thing. Now, in the new syntax, because grade here, the argument or the parameter of the function is a single parameter, the parentheses are optional. You can drop the parentheses, right? So if you refresh, there it is. So it comes back to the same thing. Also, because there's only one line of code in my function, right? Then you can also drop the return. You can drop the curly bracket, and you can drop the curly brackets. Okay. So if you re-render, notice that it's just the same thing. See that? Okay. And what else? So basically, this map becomes what? This map becomes this. That. So these 3 lines of code, right, become much more terse, much more compact. Okay. And so actually, the this function also we could use the new syntax, right? So that means that this could be rewritten like this, like that. Okay, and if we refresh, you get the same thing, right? Again, because it's only one parameter, you don't need it. Also, since really this let and return, you don't need this line, right? You can just say return this. You can say just return this, right? So you get the same output. But just like in the new, as we said earlier in the new syntax, because we only have just one line of code, you don't really need the return, right? And you don't really need the curly brackets. So basically, this table rows just becomes this almost this one-liner, right? Of just mapping through these this array, right? And just returns that. Make sense, right? So this is the new syntax, the ES6, which has made a lot of effort towards being extremely terse, right? As compact as possible, so that you don't have to write all these verbose, code to do the same thing. It's very, very productive. Okay? So that's going to be the focus of the next couple of weeks. And actually, from here on, where we're going to look at JavaScript, every single class. So we'll be introducing more and more things as we go. Okay. Any questions so far?
Okay. Prof, can you go over this line 33 and 34 again?
33 and 34. Yeah, sure. So this declares a function. This declares a function. This is the name of the function. So basically, it's a variable, and you can declare it as a constant. So I'm declaring a variable called table rows that is being assigned a function that takes this as an argument. Right, takes this as an argument. Now, oftentimes, even though the parentheses is optional, for readability, sometimes we do put the array, the parentheses, right, for readability, just so that people understand. Oh, this is a parameter in a function, and the function returns. Right, this is called the arrow syntax. Right, this is the arrow syntax. It returns this, right? Whatever that evaluates to. So the function has 2 sides, right? It has the left-hand side, right? And then it has the right-hand side. And the right-hand side is what gets calculated. And we have removed the curly brackets. We've removed the returns, right? Because it was only one line. If you had multiple lines, then you can't do this, right? You have to have the curly brackets, and you have to have the whole body of the function. Okay. So this is iterating over the array attribute, which is being passed in. As it's iterating over the array, it's calling an embedded function in here. It's calling a function that, again, these are the parameters of the function, which is, again, sometimes as for readability, we might add the parentheses back in there just so that it's clear that this is a function and that's a parameter. So this function evaluates to this, meaning it's going to call some other function here that returns this tr, right? And so this whole thing, these are going to be appended into a new array, So this array evaluates to a new array, which each element contains these strings, right? Each element is this string. So then we join them. We join all those elements in the array, right, to make a meta array, a bigger string, right? And that's what gets this evaluates, right? So one big array, one big string that contains a whole bunch of these TRs. Okay. Let's practice. Let's see this table row. Let's convert it into its new syntax. You say const equal and the arrow. Right. Again, this is only one single line. It's just a single line. So basically, we don't need the return. We don't need the curly brackets. And we can remove that. So it evaluates to this, right? Right. So this is the equivalent, right? If I refresh, that's it, right? It just evaluates to that. Again, whether we need the parentheses or not, right? It's optional because we only have one argument. But for readability, it's easier to read if we put the parentheses in there. Okay, so this renders just the same. Okay. All right. So yeah, so we're going to be spending most of our time throughout the semester using this new syntax. Right. You'll see me today and this week use both syntax. And we'll practice going back and forth, right? But preferably you'll stick to the new syntax. Okay. You'll find that you might be more familiar with the old syntax, but certainly the new syntax is much more powerful. Okay, so I encourage you to move over to the next one, next syntax. Anyway, yeah. So let's see. Binding elements, events, alerts, functions. Right, we talked about functions. Okay, so all this code that we've been writing here in the script tag, right? So we should not be writing code in the script tag. So instead, what we should be doing, right, is putting it in a JavaScript file. So let's create a JavaScript file and call it index.js. Okay. And so what we're going to do is that we're going to move all the source code, right? We'll move it, copy, all right, and we're going to move it to the JavaScript. There it is, into the JavaScript file. Okay. And in here we can say source, right? We can point to the file index.js. And if we go, we render. Notice that it works just the same. Okay. Now the ordering here matters. The order matters. And notice that this script exists after our H1 inside of the body. See that? And that's not quite right. Right. So notice it's working fine. If where the script should be syntactically correct is that it should be here in the head. Right. This is the syntactically correct position of the script in the head. Right. Now today we accept that you erroneously, well, not erroneously, deliberately put it here in the body, right? Even though syntactically that is not correct, we accept it in the industry, right? We accept it as a very valid place to put it, as opposed to putting it here in the head. And the reason is that some of these libraries, some of these JavaScript files could be fairly big, and so it might take half a second, a second to load these JavaScript files, right? And the rest of the content is not going to render, right, until this JavaScript runs, okay? And it's downloaded and executes, blah blah blah, right? So it might be a while before the user actually sees any content. Okay, so that's not a good design. So today we would typically put all these libraries at the bottom of the body tag, even though technically it is not syntactically correct, right? But the browser works just fine. All the browsers understand this hack, right? The second reason why we don't put it here at the bottom, why we don't put it here at the top in the head, is that notice what happens, right? If I refresh, notice what happens here. See that? Welcome to JavaScript. Got it's the original text, right? And it failed. It ran. It has an error, right? If you look at the console, there is a type error. Cannot read property null of style. what's all that about, right? If we notice, it gives you the error where it happens. Notice that it tried to retrieve the element welcome by its ID, but it didn't find it. So this high is null. Okay, so it tried to find style of null. So why couldn't it find welcome? I mean, it's the same document. And the reason is that the JavaScript file got loaded before the DOM. The DOM has not yet loaded, right? The browser never got to render this welcome to JavaScript. So it doesn't know yet. By the time it loads this JavaScript, it doesn't know that there's an element whose ID is welcome. So when it looks up this element by its ID, it doesn't find it, so it's null, and the whole thing dies. Okay. So again, this is a very common issue. So very easily we just put it afterwards, after the DOM has loaded, and then we can start manipulating it. Okay. All right. And now it works. All right. So it's perfectly fine to put it at the bottom. Right. Let's see. At the bottom, blah blah blah. Inner. Yeah, we can do values, input fields. We can grab elements from the form elements, right? So if you have a form element, right? So if you have, let's see, if we have an input field here, input, where you have the ID is A, right? And maybe you have a value of 2. And then you maybe have another ID input field, which is B, and value 3, right? So how does that render? Let's see. There it is, 2 and 3. We can programmatically grab their values, right? And then we want to maybe set the input ID of C, right, as the addition of 2 plus 3, right? So here's a so maybe we can say A is equal to that, right? And maybe go to a breakpoint, right? And we can say B is equal to B, right? We can say a breakpoint, break, and then we can say C is equal to that. All right. There we go, right? And so maybe we can programmatically grab them. So we can say maybe in index, right? We can grab const A. We can say document dot get element by ID. We'll grab A, right? And then B is document dot get element by ID of B, right? And then we can say we can grab the value. So these are the DOM elements, A DOM and B DOM. Then we can grab values. We say const A is equal to A DOM dot value. Is it value or val? I forget. I always forget. Oh, just value. Just value, like that. And we can grab B. There we go. And we can check it. We can say, we can console log. We can console log A, comma B. Let's see. We can say console, refresh. There it is. So 2 and 3. So we grab the values of 2 and 3. And then we can set the value of C. We can say C, right, is the element whose ID is C, which is this one. Right, and then we can say that C DOM, we can not only can we read the value of the elements, we can also set the values, right? Saying A plus B, right? So let's see and refresh. Okay, 2 plus 3 is 23. Okay. Yeah, so these values by default are strings. So basically this is the 2 string and 3 string. So it's concatenating 2 and 3, so you get 23. We can do an integer value. We can parse the int, parse int. Or we can parse the int. There we go. So we say parse int. There we go, like that. So now they're integers, so that when we add them, indeed is should be 5. There it is. Everybody good? Okay. We can have a little calculator, right? Where maybe we can have buttons underneath this. So we can say PR, right? And then we have a button and plus maybe, or add. Okay, so we have maybe an add button, maybe a subtract button. Right. And you can and as we click these buttons, right, we can call different functions, right? So for instance, we can have a function here, a function add, that says console.add. So that when we click on this button, we can say on click, we want to call add. What's it called? Add, yeah. Add. We want to call add. And on click, we want to call this function subtract, which we don't have, but let's try this out. So let's refresh. So we click on add, notice that it is printing add here. See that on line 3. See this right here. Okay. So what we could do, right, on the add, we could do this in the add. We can say grab the values, right, and add. So we can put this in here like that. So we call these functions only when we click on add, right? So let's see here. If we refresh and we click on add, notice that it sets the 5. Okay. Right. So you can certainly create a small little calculator, right, where you have the on clicks, where you have you call subtract, you call whatever. Okay. Let's see. Let's keep going. Blah blah. So okay, this is a little calculator where you can add, subtract. So there's also JSON. So the way we represent data in JavaScript is through a format called JSON. So JSON has become one of the more pervasive and most popular way of encoding data. It stands for JavaScript Object Notation, right? And it's basically it's a curly bracket, right, with name value pairs, where you have the properties and then the values, properties, values with a colon telling you that this is a, between the property and the actual value, right? This is referred to as a literal object, just like just like 3 here is a literal integer, right? 1300 is also a literal integer, just like there's a literal string with the quotes, right? Well, there's also a literal object, right, where you can declare the object and boom, it's done. It's initialized, exists. Right. This has 3 properties: room, bath, and square feet. That's a house. And then here's an example of taking a house, and then in the HTML, and then populating it. Right. Notice that this has empty values, but it has its own IDs, right? And basically, we are grabbing each one of those items and then manipulating them and injecting the rooms, the baths, and the square feet of the house. Okay, notice that this uses the dot notation, right, to retrieve each one of the properties inside of the object. Okay, strict. Just make sure that you don't misuse the language. We're not going to use ifs example. Okay, so all right, I think let's take a look at the assignment. I think we have enough to introduce to you the assignment. Let's take a look at it. Any questions so far? Everybody good? Time is it? We got a half hour. So yeah, so this is the 5th assignment, right, where we are going to play with JavaScript. Okay, so let's create a let's see, a branch let's see, git branch. Okay, so we are on A4, git status. We have it in here. Okay, so we added all these files. That's fine. Let's git checkout minus B and then A5. And let's leave those files for now. So let's create a directory where we can work on A5. Let's see this in the labs, A5. A5. A5 is going to have index HTML, but it's also now going to have an index.js as well, right? So it's going to have an index.js, perfect. And it might also have an index CSS as well. So let's add that. So this is index.css. Okay. All right. So in the HTML, what we're going to do is that we're going to link the CSS. We're going to say link, and this will be href index.css rel style sheet. Perfect. Okay. And the script, we're going to add the script here. We'll say script. We're going to bring in the source. Index.JavaScript, perfect. Okay. Notice you need that closing script at the end, right? And so this is assignment. So this is assignment 5. Assignment 5, JavaScript. Okay. And let's run this. So let's run. And there it is, right? Okay. I'm going to move this to the right. I'm going to have this side by side so we can start playing around with some of these assignments, some of these exercises. Okay. All right. Okay, so the assignment walks through several samples, like hello world. So we're not going to do that, right? And then moving all the code to index.js. We did that already. We can write to the console, right? Console hello. We just show you how to do that. And then there's a whole bunch of exercises on how to work with different types of data. Introduces global variables. You should avoid global variables at all costs. So do not declare variables, right, that don't have var, or const, or let, or anything like that. Right. So here's an example of what not to do. So you should not declare that, but I mean, I walk you through doing it anyway. It's also here we have a var is a variable declaration, although it's part of the legacy syntax, it's still supported, still there. But I would discourage you from using it at all. The two that we're going to be using throughout the semester is these let and const. Let and const, right? Although in the examples or a code that it's out there, you'll find the var is still widely used. We should start flushing that out. So all these examples ask you to do the following: you copy the example, and then in index.js, you paste it, the code, and just play around with the code. Basically, this is you're going to print out a little introductory message, right, of what the exercise is all about, variables and constants. And this is what the TAs are going to look for, right? They're going to look in the console for that text, right, to verify that it's printing what it's supposed to print for whatever section you're working on, whatever exercise you're working. So this declares 4 symbols: global 1, function scope, block scope, and constant 1, right, which is the addition and subtraction of these two. So you're supposed to print this out to the console. So you need to add the following. The exercises don't do it for you, so you have to do it. So console log global, just print it out to the console. Console log the function scoped, right? Each one of these. So each one of these. So there's 4. So print these 4. So console log. All right, so I'm just going to copy this. So you need it again. And this is block scoped, and this is constant, which is the summation of these three actually. So when you run this, you won't see anything in the console, in the document, right? But it'll be printed out in the console, right? If you go to console, there it is, right? 10, 2, 5, and 7, right? And that's what the assignment says you should see, right? So on the console, that's what you should see, and that's what the TAs are going to look for, right? So make sure that you work through these, right? So for instance, this one doesn't tell you, right, to do any of the console stuff. You have to do that yourself. Let's see. Yeah. So this just introduces the fact that we have different data types, and the data types in JavaScript, they are inferred, from the values, right? So for instance, this one is inferred as an integer. This one is inferred as a floating point number. This is inferred as a string. This is inferred as a Boolean, right? And you can also use the type of, right, to determine the data type of the variable. Right? So for instance, type of and then number variable is number will be the value number, the string number. So this is a string number, string, and Boolean. Okay, so these are strings. These are just playing around with some Boolean variables, right? So true 1, false 2, right? Just introduces you playing around with Boolean expressions with the and. So, and 2 ampersands make an and. 2 vertical bars make an or. You have the not operator, right? You have the triple equal operator, right? That it's comparing whether these two things are exactly the same, right? They're identical. And there's another operator which only has 2 double equals. So there's an equal, which is an assignment operator, right? This equal here, that assigns the right-hand side to the left side, right? The double equal is a comparison operator. It's asking, is the right-hand side and the left side, or sort of the same? So, which is not good. Right? Don't use it. So, for instance, I guess I would give you the truthy operator. So you could say truthy, meaning sorta true. I'll call it, sorta true. Yeah, more or less they're the same. For instance, if I say character 1, right, equal 1. Okay, and so this would come back as sorta true. That's almost true. Because the double equal will try to cast the parameters on either side to a data type that can make this true. Okay, so whereas the triple equal will not do that. The triple equal will check to see, the first thing that it'll check to see if the two sides are of the same data type. If they're not the same data type, it's not going to even take a look at it, right? So this is sort of true, and this is not true, right? So not true is that if you do the same thing with triple equals, this is not true, right? Whereas if you use the double equal, then this returns as true, right? It's yeah, sure, it's true. It's like truthy, right? Yeah, so try that. Conditionals, obviously you have all the if else, right? So where you can say, if it's true, this runs, if not false, right? So all these you're familiar with. The one that you might not be familiar with is the ternary conditional, right? Which I believe JavaScript has, Java has this, I believe, right? So let's take a look at this real quick. Let's put this at the top. So here's a ternary, and let's see what this is do. What is this doing? Let's take a look at this. So this says ternary conditional operator. Okay, so I'm declaring a variable, a constant, to be true. So I'm asking, is this true? Well, obviously it is true. So this, notice the question mark here. This is saying, you're asking, is this true? Is this true? If it is true, notice that this is there's an assignment operator here. So greeting is going to be assigned whatever the right-hand side evaluates to, right? So greeting will be equal to whatever this evaluates to. So what does that evaluate to? Well, notice the colon sign here. See that? So this whole thing will either evaluate to what's on the left side of the colon or what's on the right side of the colon, depending on whether this is true or not. If it's true, then it evaluates to the left side, right? If this is false, then this evaluates to the right side. Okay, so what does this evaluate to? This evaluates to welcome, right? Okay, so if we run this, there it is, welcome. See that? Now, if this were false, right, and we refresh, notice that it prints out, please log in. See that? Okay, so it evaluates to different things. So greeting evaluates to different things based on the ternary operator. Very, very useful operator. We'll be using this a lot. Okay, it's very, very useful operator. Okay, functions. We talked about functions, right? This is the old syntax. This is the legacy ES5 syntax, still widely used, but I would discourage you from using it going forward. Here's an example. I ask you to implement, using the legacy ES5 function add, right? And then you just call, add 2 + 4, and then implement it, subtract, subtract using the new syntax, right? So declaring subtract with now here, subtract has 2 parameters, right? We're going to pass 3 and 1, and because it has 2 parameters, you cannot the parentheses are mandatory, right? If it's only 1 parameter, then you can drop the parentheses, but because there are 2 parameters here, you definitely need the parentheses. Okay, so what does this evaluate to? The body of the function is this. It returns a minus b, right? So this returns 3 minus 1, right? This returns 2. Okay, all right. Okay, so here's multiply, which we could have written very much like this, right? So this could have been multiply, AB, and this returns, A times B, right? Multiply. But, right, the new syntax allows you to have the right-hand side, if you only have one thing that you're doing, right, and you're returning that value, right, we can drop the curly brackets, we can drop the return, and notice how nice and compact that is, right? That would have been what? Would have been curly bracket, return, blah, 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 right? Would have been something like that. And would have been very verbose, unnecessarily so, right? It would have been something like that. Notice how much readable it is if we can just drop the returns, drop the curly brackets, and you just end up with this. See that? And that's why, right, the new syntax allows to do this, right? So that there are cases, there's some nice little edge cases that really the language makes it so much easier to read. Okay. Now, the problem with this, of using this syntax, is that you can't debug this, right? If you want to step through it, put a breakpoint, anything like that, right, then you can't. But with this syntax, you can, right? With this syntax, you can put a breakpoint on that line and see the values of A and B, right? So there's pros and cons, right? If you do this very terse syntax, you can't step through it. You can put a breakpoint here, but you can't put a breakpoint here. Okay. Also, optional parentheses. Here's a function square and +1. that square basically just takes the parameter a and returns the a times a, right? Since since it's only one parameter, no parentheses, and it evaluates to this, so you can drop the return. Okay, so here's square 2, plus 1. Arrays, we played around with arrays. Here's a couple arrays. Here's an array with numbers, an array with of 2 strings. And here's a variable that allows you to mix and match. So arrays can be of the same data type, and they should. You should keep all the same data types in an array, but arrays don't care. You can mix and match all sorts of stuff, right? Constants and doubles and floats and other arrays. You can put arrays within arrays, right? You can mix and match. You can put functions inside of arrays, right? Here's a couple of things you can do. Arrays. You can do length. You can search an array. Say, does this array contain this value, right? Where is it found? So you can add things to arrays. So arrays in JavaScript are mutable, right? You can add elements to the end of the array by adding 6 or adding a string. Okay. You can remove things from the array by using splice. So splice says that starting remove one item, you can remove multiple items, right? Starting at a particular position. So at position 3, drop one element. So notice that 3 is no longer there. See this? We got 1, 2, 4, 5, 6. And from the string array, we had 3 strings. I think, yeah, we had. Oh, wait, no, what? 1 and 2. Oh, we had added a string. Yeah, we had pushed a string in there, so we have 3 strings. And then we removed the second one, so you ended up with string 1 and string 3. Very good. Okay. So loops, right? You have multiple. You have the normal loops, right, where you iterate from 0, right, from one starting point to the length of the array, which is what most people identify. But there are many more very, very powerful functions. The map. So let's take a look at the map again. Let's play around with the map. So let's see. Let's maybe at the end say, let's do console log. Oh, actually, maybe we can do document write. So document.write, right? So let's declare an array. Do we have an array? Oh, I thought we had grades. What happened to grades? So we have grades, right? And so we have 90. Okay. And this is const. We have grades. And let's print that, grades. Let's see what that does. There they are, right? As an array like that. And probably, so what we could do, we can calculate the squares of grades, right? We can say const grades square, right? We could say grades. Well, we can do a map. So we could say, as you iterate over the array, pass me each one of the grades, right? And so you can put I'm going to use the old syntax. So it's a function, just a regular function. There it is, right? And I'm just going to put it in a separate line like that. Now, some people are put off by this syntax. It's a very common syntax in JavaScript where you pass as an argument. You pass a function as an argument. That's a very common, and it's becoming very common in other languages as well. It's just basically using lambda syntax, right? Where this is a function. Notice that this function doesn't have a name. See that? So this is a one-off function, right? It's a throwaway function. it's no one else can call it. Only the map function is calling this function, right? As it's iterating over each element of the array, it's going to call this function, and it's going to pass you two things. One, it's going to pass you each element of the array, which are grades, right? So here's the grade. Okay, so it's going to pass you grade, and also it's going to pass you the index. You know, which grade is it? 0, 1, 2, 3, and so on and so forth. Right. So and what it does, what it's going to do is it's going to take whatever this function returns, and it's going to accumulate it into a new array. Okay. And that array, the result of accumulating all the individual elements into this new array is going to be what returns from this map, right? And we're going to assign it to grades. Okay. So let's return. Let's return just grades for now. So the same value that you gave me, the grade. You give me grade, I'm just going to return grade. Right? And let's print it out. Let's say document dot write grade square. So let's see. Let's refresh. Okay, so it's putting it in the same line. We might need to add a break here. So let's say document. Let's add a break here. There it is, right? Perfect. Okay. Maybe add some. This is gonna say grades equal, and this is gonna say grade square equal. There they are. So we have grades and grade square. Okay, they're the same. Right? Obviously they're the same. But what about if we want to square them? Probably we can just say grade times grade. So there it is, right? So these are the squares. 90 square, right? 89 squared, 78 square. Let's put one easy one so we can know this is correct. 2, 3, 4. Okay, there it is. So 4, 2 squares 4, 3 squares 9. Okay, good. Everybody good? Now, obviously, this syntax is very verbose, right? So verbose. So we can also notice that the index we're not using it for nothing, right? But let's see if we can replace this with the new syntax, so this becomes much easier to read, right? So this still returns the same thing, right? Also, since we don't have index, we can just remove that, and because now we have a single parameter, we can drop the parentheses, and because we have a single line here, right? We can drop the return. We can drop the curly brackets and return, and then we're just left with this. That's all we're doing, right? Now we can just bring that over, right? And then it becomes very, very compact. Okay. And we just return the same thing. Everybody good? Okay. All right, excellent. So and this could be a function, right? We could declare, let's see, is there a question on the chat? Let's see. What if I need only index? How do I get that only? You can't. You need to ask for both of them. Yeah, you need to ask for both of them. So grade and then index the second argument. Yep. Okay, so let's play around with some more. Let's see. Okay, so we have the grades. Let's see. Let's put some more values here. So this would be 56, 45, whatever. Some more values. So for instance, you can now, for instance, do other calculations. You can say, const passing grades, right? So the passing grades would be a subset of these arrays. You would say maybe it's all the grades above 60, say, right? Or something like that, right? So it would be, I want to take the original grades and I want to filter them, right? I want to filter, and I only want those grades that meet a criteria. So again, this is a function. This is a function that is going to do the same thing as before. It takes the grade, each one of the elements, and the index, and then this is going to keep some elements of the original array, the ones that I return here as true. If I return true from this filter, from this function, then it's going to keep the grade. If I return false, it's going to skip over that element, right? So I'm going to say, well, I'm going to return only the grades, right? If it's greater than, say, 65, right? So it's a passing grade if the grade is greater than 65. And otherwise, it's not a passing grade. So passing grades is only going to keep what? These here. That's it, right? Right. So let's do that. So let's display that. I'm going to say new line here. So passing grades. Let's see. Passing grades is passing grades. So let's display that. There it is. So now passing grades is only 90, 89, 78, and 67. Make sense? Okay. Let's see, what else? What other things that the assignment asks you to play around with, right? So finding, you can find the actual element, right? You can find the location of where is it, find index. So for instance, you can say where, right, in this array can I find something, right? Where is 67, for instance, right? That it's in position 0, 1, 2, 3, 4, 5, 6, right? So I could say, const where is 67, right? So you could take the grades array, and then you can say find index. So you can either retrieve the element itself or ask where is it in the array, right? So find index, again, function. I'm going to use the new syntax. So here's the grade and here's the index. And where is 67? Well, it's where grade, right, is equal to 67. Okay, so it's going to return, whenever this returns true, right, then it'll stop looking, right, and it'll return wherever the index is. Okay, and because I don't need the index, I'm just going to drop that, and it just becomes this. Okay, sometimes, if this is too long, we can break this into 2 lines like this. So grades dot find index, and we can display that. Let's display it right here. BR, where is that? Let's display that. There it is. So it's in location 6. We can also maybe, modify this into a that, and this could be like that. So there we go. So like that. And I guess we can put the breakpoint. We put it maybe at the end, right? So that we remember to put a breakpoint. There we go. And that renders like that. Very good. So it's at position 6. See that? Let's see what else. The assignment asks you to do all these, right? So you're going to be practicing all these functions: filter function, template strings, right? We've been playing around with template string already. Writing to the DOM, we did document.write. Here's a little bit of to-dos, right? Where we render the map. Okay. Oh yeah. So here's a nice little one. So for instance, if you have an array of to-dos, right? So here's an array. You say const to-dos. So here's an array of to-dos. Oops. And the assignment asks you to implement a to-dos editor. So you'll be planning, being able to add a to-do, remove a to-do. So for instance, this would be maybe an object where the actual to-do is, buy milk. Okay, and let's say we have a couple of to-dos. So buy milk, pick up kids, and walk the dog. Okay, and so we might display this. So this could be document, document dot write. We're going to display to-dos, and we're going to render this as an expression, to-dos, and then just put BR, right? And there's our to-dos. Oh, okay, so it's iterating. Those are the different objects. We can display, okay, it doesn't know how to render the objects, right, as string. So it's just putting this curly bracket saying, yeah, that's an object. I can't render it. But we could do as follows. We can say document.write. So it's a string. It's an expression, right? And so this is going to be what? It's going to be a UL. It's a UL. And what is this going to be? This is going to be an LI, right? It's going to be a whole bunch of LIs that it's going to be iterating over these to-dos. That's correct, right? And as it's iterating over the LIs, each item, what do we want to do? We wanted to create a whole bunch of LIs, right, as it's going, right? We wanted to generate this, right? LI, right? Buy milk. This is what we wanted to render, right? Buy milk. Pick up dog, kids, right? Walk dogs. That's what we wanted to render, right? Right. So let's refresh. Yeah, that's what we wanted to render, but we wanted to do it programmatically, right? Not hard coded. So how do we do that? Well, isn't this the concatenation of multiple strings? Isn't it? Right? One per item in the array, isn't it? Right, so it's the concatenation of multiple LIs as we iterate over the array. Well, we have something that does that, right? That can iterate over the array. And as it iterates over the array, it's going to accumulate a whole bunch of strings that we return. So let's do that, right? And so it's good. It's going to be an embedded string. So when it's embedded string, right? That is going to iterate over the to-dos. So to-dos, right? Map. So it's iterating over the to-dos. So here's the to-do, each one of to-dos, and it's going to evaluate as what? As a string, li, okay? That contains what? The to-do dot. So to-do is the object, right? So maybe we should call it the to-do object. So to-do object, right? So each one of these, right? This, each one of these. So this is to-do object dot the to-do, the actual text. Okay. See that? All right. So let's render that. Oh, well, this whole thing is an array. It's an array of strings which we need to join into and just drop the commas. There it is. There we are. So notice that this array was generated dynamically, whereas this one was hard coded. See that? Okay. We can break this up a little bit so that it can be a little more readable. We can break this into this like that, and then dot join here. Or we can say to-dos that map. Yeah, there it is. Okay, actually, no, that's easy to read. See that? right? So this, right? Actually, this is going to become a very, very common thing that we do all the time in React.js, right? React.js uses map very, very widely, okay? So yeah, so notice how we're able to embed that very nicely. Okay, everybody good? Still with me? Okay, so let's see. Yeah, so this asks you to play around with this a little bit. Okay, so we're going to be using a library called jQuery, and I know I'm running out of time, but and jQuery is a library that is worth taking a look at. So what happens? jQuery is a library that solves a very important problem. It's the that as folks were using more and more JavaScript, um, and they found that that they could not control how the user was going to use their web page, right? Different users were using Chrome, others were using Safari, others were using Firefox, Mozilla, Opera. God forbid they were using Internet Explorer. And so it became very, very fragmented. Each browser implemented JavaScript slightly differently. And also the browsers were different versions. And so even within the same vendor, each vendor had different versions of JavaScript and they were not up to date. So it was a mess for us developers to code JavaScript and in any consistent way, so that we coded once and then it ran the same way on different browsers, right? Remember, we write the code, but whoever's going to read this, some folks, I'm using Chrome, right? I'm using Chrome, but we can't guarantee how people are going to consume our page, right? So it was very, very hard to write code that worked consistently across all browsers and all different versions. The code, developers started using lots of if statements and switch cases, right? That detected which browser, which version, and depending on the version, do this. If you have this vendor, do this other thing. It was just a mess. So jQuery solved this, right? What jQuery did was that, you know what, don't use the low-level JavaScript API, right? All this document and write, document find by ID, blah blah blah, right? Don't use this low-level API. Instead, use ours. We are going to translate. When you call our API, we will figure out for you, right, which browser version, which vendor, right, and we'll translate whatever you use for our API. We'll do the right thing, right? So instead of using .write, document.write, use our append function, okay? And we will figure out what to do, right? To whether how it behaves here and there. Okay, so anyway, this is where we're gonna continue later this week, right? We're going to install jQuery and play around with this. The assignment asks you to grab it from a CDN, right, or install it locally, and then start playing with it with a hello world, bind it to the DOM. So grabbing things from the DOM. What the jQuery library, what it does is that it when it gets installed, it declares a global variable called $, right? Or jQuery as well. It declares two. $, is an alias to the jQuery function, and it allows you to retrieve things from the DOM using CSS, right? So you can say, hey, grab the element whose ID is bind by ID. Here it is, bind by ID. Which, this is the equivalent of saying document dot get element by ID, right? So that's much more verbose. So that gets compacted into $, hash bind by ID. Once you have it, then you can do things such as, or you can grab things by class, you can grab things by ID, using, standard CSS selectors, right? And then you can, you can change the style, the color, the foreground. You can change attributes. You can apply different attributes. You can create new classes. You can add classes to change the look and feel of something. So anyway, this made it so much easier. This is one of the most successful libraries ever in JavaScript. But it introduced the notion of creating a small thin veneer on top of the browser, kind of like an abstraction layer, right? So that instead of talking directly to the browser, we were talking to this thin veneer of a jQuery, right? And then this opened the floodgates for ever more sophisticated libraries, right? That created an even thicker and thicker and thicker layer of abstraction up until you get to Dojo and Angular and React.js. Those are all libraries, right, that abstract the underlying browser and create a model of how you can start thinking about creating these dynamic components, right, programmatically, using a modular, reusable model. Okay. So anyway, yeah. So we'll talk about this some more when we meet next. Please take a look at the slides. Look at the assignment, and if you have any questions, let me know. Right. Again, remember tomorrow I have the office hours in the morning. Although I'm going to start doing at least a couple of hours a little later in the day, so that folks from the West Coast can also participate. Right. You have any questions, anybody? Let's see. Sorry, John. Was there an update on the quiz? Yeah, the quiz 2 will be made available right after this lecture. Any questions? Anything else? All right. Thank you, everybody.